All right, somebody complain about something. Blah, blah, blah. You know what I say about that? Wag kanya magreklamo. Is that close? Wag kanya magreklamo. Wag kanya magreklamo. Am I telling you to quit complaining?
Yeah.
Or stop complaining or something along those lines? Okay. I'm very thankful that somebody didn't punk me and I just said something really offensive. All right. So here we go. I need your help. I'm just going to jump in at C. We had two functions, f of x and g of x, and we were multiplying. In your notes from yesterday, you have this written, f times g of x. And then I asked you guys to find it, and we plugged in and said it was probably just f of x times g of x. And I need your help with it. What was f of x? What did we have as my functions? Because I don't know how we defined them. We didn't define them? Oh, interesting. Okay, I am confusing us. Can I see somebody's notes? Because I do something very different in 5th and 6th. Oh, okay. All right, so easy enough. So we say that this is just f of x, what? Times g of x. Now, as we look at these, we have now 3 different properties written on the board, right? Or in your notes at least. Did I call it A, B, and C, or did we just use asterisks? Okay, so I'm going to catch up to you then so it looks the same. We have this equals, goodness gracious, holy tech issues, f of x times g of x. We agree with that. Okay, and then we had, I'm going to write this as 1, f plus or minus g of x equals what? F of x plus or minus, the same order, g of x. So those are the properties that we had yesterday. Cool. Let's get one quick example with this, and realistically we're just going to define a couple functions, and by one quick example there's really 3 parts to this problem. Okay, so we're just going to see right off the bat how it goes. I want you guys working together, see if we can't reason these out with these rules available. So let's write some functions. We're going to let f of x equal some function. I don't know what it is. What's your favorite function? X squared plus 2. Okay. And g of x is, let's make it x cubed plus 2x minus 1. Now, I'm going to highlight something really quick that we're going to touch on. We'll probably define it, but I'll promise I'm going to show you, or at least get the idea in your head of a much larger, more important math concept that is going to show up, and we can hit it here. You've actually been using it your whole life. You've just probably never been aware of it. I want you guys, for this one, what do you think I'm going to ask you to do with these 2 functions, f and g? Maybe factor, but we don't know how to factor this. Not yet. We will. What did we talk about yesterday? How we add, subtract, and multiply 2 functions. Now, we never said that explicitly, but do you agree that's what we have written on the board? Hey, so check it out. What I want you guys to do is f minus g of x. I want you to do f plus g of x. And last but not least, I want you to do f times g of x. Now, I'm starting with one that will do this one first. If you finish it and you're confident with your answer, you can work with your neighbors. We'll obviously talk about it, but just a forewarning, I'm anticipating almost all of you will make a mistake. And I think I know what the mistake will be. You might not now that I've pointed it out, kind of. But I want you guys to try these out. Only thing I'm going to do so that my work is a little bit easier to follow is I'm going to replace my x squared, is that minus or plus? Because I already forgot. X squared plus 2. Okay, so all I'm going to do is I'm going to replace it with white so that I can keep my function straight as I'm looking at it and setting it up. F of x, what? F of x is x squared plus 2. Okay, so I'm going to give you guys a moment. I want you, based on the rules that we defined yesterday, I want you to try to do this one. I'll give you a minute or 2. I'll be walking around. Let's check it out. as we look at this, my advice, and as we're doing this, like obviously I'm not showing you how to do it first because I want to see what you guys have. My immediate first step with these, at least in the very beginning stages, is I'm just going to rewrite this. Now, I see that the amount of space I have. This expands to be f of x minus g of x. Is everybody okay with that first statement? F of x minus g of x. Now, this problem is different than the ones that we did yesterday, specifically because do we know what both of these functions are? We do, right? We just defined them. Once I write this and I say, check it out, here's the rule that's going to work nicely, can I just substitute in? Like, instead of f of x, what do we know it is? It's x squared plus 2. Now, I've added parentheses. Do they do anything? No, not right now, but it's a good piece of advice. You're going to subtract something from this. If you haven't started actually doing the problem with the concrete stuff, I want you to subtract it. If you're done, let me know. I'll come take a look. I'll give us about 60 more seconds if you didn't quite understand what I was asking you to do initially. Cool. Some of you guys are doing really well with it. Good. Some of you aren't. Good. Like, that's fine. We're going to learn it. We're all here for the same thing. As we look at this, I'm going to make a huge mistake. And I want to see if you guys can pick it out. Because I now need to subtract g of x, right? And what's g of x?
3 cubed plus 2x minus 1.
Okay, so that's just a misspeak. That's okay. I think you meant x cubed. But, okay, I've made a fundamental flaw, a blunder, if you will. But I've been playing a lot of chess, just for the record. What did I do wrong? No parentheses. Do they matter? So kind of or yes very much? Why? Zed, what you got? Why do my parentheses matter? If I don't put parentheses, there's no reason for me to distribute that negative. Because the whole function is being subtracted, there's a 1 out here, right? Like, I can distribute it and get rid of my parentheses. They don't really do anything. If I don't have the parentheses, though, we're going to be wrong because the whole function g of x has to be represented. And all I mean by that is I'm going to distribute the positive 1 that I didn't even bother to write to this one just to get rid of my parentheses. You do not physically have to write this. Like, if it's a positive 1 outside, you can just drop the parentheses and nothing changes. This one, though, there is a bigger impact. What does this give me? Negative x cubed, and this one? Minus 2x, and this one? Plus 1. If we don't distribute, we have no hope of being able to get this. Now, as soon as we do distribute, we get this either lovely or terrible expression. I'm not going to switch colors anymore. Can I simplify this? And what would that even mean? Yeah, we want like terms, and then I'm also going to write this polynomial in standard form, which means what should go first? The highest degree. And what is the degree of this whole function when we add them up? So I think it's negative x cubed, and then I like to do a really light brushstroke through it just so that I don't forget that I've already taken care of it. Negative x cubed. What's next in my standard form of this polynomial? X squared is next, right? We always just descend. Is this positive or negative? Positive. X squared. What comes next? Minus 2x plus 3. If you did not distribute the negative, you're going to get a lot of similar looking stuff, but you're not going to be correct. You're going to have different terms around. The negative will destroy you. Anytime you're plugging something in, ever, whether it's for x or it's for a bigger function, my best advice to you is parentheses around it. It will help keep everything straight. Okay, this I think is the hardest problem of these three. I want you guys to do Bravo if you haven't yet, and then we'll talk about this one together. Cool. Before I just pause it, any part of this that's not clear for anybody, what questions do you have? Okay. I'll be walking around if you're just being too shy to ask. Cool. All right. Do Bravo for me. I'm going to give you a head start, and I'll work it as well. I took the liberty of writing the first couple steps that if you struggle with it, this is like what I would write every single time. Some of you don't need to write this every time, and that's okay. I'm totally cool with mental math stuff. But remember, if you do mental math and I can't follow, or it's not clear what you've done on a test and you're wrong, what happens to all your partial credit if I don't see it? They're gone, right? Like I can't give you any if I don't see it. Looking at these, on my next line, if I wanted to be showing every possible step, we substituted in here, sort of. We just expanded that rule. Then we did our substitution. And then what's my next line going to do if I wanted to write it? So that's what I would naturally do. Could I distribute the positive ones and get rid of my parentheses? Now, this one is a weird choice, kind of, because I don't know that I really needed to write this necessarily. Nothing changed. If you want to make sure everything is crystal clear, we've distributed the 1 and just taken away our parentheses. In reality, when I do these, when you do these, if it's a plus something in parentheses, we should just drop the parentheses or imagine that they're not there, is what we should do. Okay, like terms and standard form. What comes first out of these 5 guys? X cubed, love it, plus what? Plus x squared, plus what? 2x plus 1. Because a positive 2 and a negative 1 combine to make this. Okay, on this last one, we're going to talk about it together. I want you to know I do think that you can do this problem without me. I do think so. But if anybody in here struggles with stuff, this is a good chance to make sure that we get this. Now, I know that f times g of x expands how? Good. F of x times g of x. And this is a good practice. Some of you inevitably, and I'm just going to check, anybody not written this first line on any of them? All right, that's okay. I will tell you, we're going to get to an idea later in the chapter called composition. You are going to write it then, okay? Like, I'm okay if you skip it for now, but be prepared. You're going to have to at some point. Okay, when I do this, I'm just now going to do what? Somebody quietly whispered the right thing. Say it again, but don't quietly whisper it. We substituted with chutzpah, I guess, is the word I'll use there. Cool. X squared plus 2 times, can I just use all yellow, or do you want me to switch colors? Ooh, there's a Coldplay song like that. And it was all yellow. All right, yep, we're going to listen to that here as soon as we're done. All right, the F word fails us here. Now, why do I not want to use FOIL? There's more than the first, the outside, the inside, and the last, right? Now, when we're looking at these, have you guys multiplied things like this before? Okay, how many of you physically draw the lines when you're doing distribution? And by that, I also do it. By that, I mean these, right? Okay, if you do or don't, that's fine. If you struggle with multiplication stuff, I would encourage you to draw them. Let's FOIL this thing out together. I'm going to slide a little bit this way. What's x squared times x cubed? X to the 5th. Okay, what's the next part of my distribution I need? X squared times 2x gives me 2x cubed. X squared times negative 1. Negative x squared. What do I do next? The other one. So we'll go here, right? 2 times x cubed is 2x cubed. 2 times 2x. 4x. And 2 times negative 1? Negative 2. Now, this is the order that I would always encourage you to do it in. If you are really good at foiling stuff and you can see what's coming, there's certainly a possibility that as long as you have all 6 of these multiplications, I don't care the order that they happen in. When I do this, for anybody who's maybe wanting to skip a line of work and comfortable with it, I can do x to the 5th. And I realize that my next biggest power is going to be an x cubed, right? So I might do this, I might go x squared and 2x and do this one next because I get a 2x cubed. And then I might do the 2x cubed and just simplify throughout as I'm doing it. If we need to expand it, we can avoid any mistakes that you might make with mental math. Are there like terms that I can combine? Okay, so let's write this new thing in standard form. What's the degree of this new function? X to the 5th. So 5 is a degree, but it starts with x to the 5th. And I'll light cross it out. What's next? 2x cubed plus 2x cubed is 4x cubed. And we'll light cross through those. And I'm just looking, do we have squares anywhere? Just one. Minus x squared. Only one term with just x, which is my x to the 1st, but that's how I refer to it as just x, plus 4x minus 2. Okay. Now, it didn't happen on this problem, but I do just want to make sure you don't have to write this. If I had given you instead g times f of x, which is same thing, right? F times g or g times f. But if I'd given you g times f, and this is just a thought, so we don't have to physically write it down, but it would have shown up like this, x cubed plus 2x minus 1, and then we would have multiplied it by x squared plus 2. Now, in this situation, how would you draw your lines? Would we do 1, 2, 3 like this? 1, 2, 1, 2, and 1, 2? We could. I wouldn't. That works fine. It's weird to do, but we could distribute from either side, right? It doesn't really matter. If I were doing this problem and it spit out backward, I think it's easier to do 2 sets of 3. And all I mean by that is notice I have 2 little places where I drew 3 lines. I could do that like this as well and just work it this distribution. Sonny, do you like the look on your face makes me think that you don't really get what I'm saying.
No, when you said 2 sets of 3, I thought, it working out.
Okay. That's where my mind went automatically also, fellow gym rat. All right. Cool. Gym rat's not a bad thing, right?
No.
Okay. Like that's just a person that hangs out at the gym. Okay. Cool. Do these seem crazy hard? All right. Now, some of you in here, and I know that like many of you are like too young to really have a full big grasp of this. Before I go on with this little tangent, sort of, questions about any of these 3 that you have, something that you didn't understand. King, hit it. Only if I tell you specifically that's what g is. Like on your homework, there will be g of x is a different function. Just use whatever they tell you it is. Okay. Now, how many of you guys in here have any idea, even a maybe, of what you want to do after high school? Okay. So some of you probably have, like, you know what you're interested in at this point, at least kind of. Hopefully you'll find more stuff that you're interested in as time goes. Some of you in here, anybody planning on being a mathematician? So pretty rare. Like there's not many pure mathematicians. Like that is not a very common thing for people to study. Anything STEM related? STEM is science, technology, engineering, and math. So if you're going to do something with computers or engineering or architecture or anything like that, any of the sciences, even if it's biology or chemistry, that would still count as STEM stuff. Okay, for that, those of you that might ultimately take like more math classes, obviously many of you will take more math classes with me, like I'm hopeful of that. But if you wind up taking stuff in college, when you are eventually studying higher level math, you wind up getting to classes where it becomes much more about why does this all work than how, like, what do we do? So we start investigating all this stuff. Now, there's one big idea that your book makes it a point to define. We're going to get this and then we'll do our brain break thing, okay? Okay, one big idea that your book defines for us, and I've never seen it mentioned in a lower level class, but I love it, and it's awesome. We are going to define, and we're going to define it now, and we're not going to go like crazy into it, but it's sweet that it shows up. We're going to define, following this example, an idea that I don't think you guys have ever seen in math, and specifically, it is the term closure. Okay. We're all looking for a little closure, right?
That takes to a closure. Yeah.
I hope so. That's what I wrote.
Closer.
Okay. We are looking at closure. Now, do you know that word?
No.
It means, like, that's a harder thing to say what it means, but what word do you know that's kind of like that? To close something. All right. If I close the door and it's locked and or you don't know how to use a doorknob, anything that we do, no matter how I move you in here, you remain in here. Do you agree with that? Okay. So we are looking at, if we want to make it mathy, we right here form a set, a collection of 23 of us in here right now, I think. 23 people in here. No matter how I move or group you together, whatever the case is, do you agree that all 23 of us stay in here? Now, if we were adults, and let's say I was I'm an adult, you guys are young adults, you're close. Let's say that I'm pregnant and I have a baby while we're in here. Weird, but sure. Would the baby be in this room as well? So it would remain in this room with us. Same thing, if any of you all of a sudden decided you wanted to be like some weird sea animals and you butted off yourself and you made a new copy or a clone of yourself, would you also be in here? Okay, we would be in this closed environment forever. That's a weird idea. I just didn't want to say that you guys are having children. Okay, as we look at this, when we look at what we just did, we started with 2 polynomials. Is everybody okay with that? Okay, there is a big set or a big collection of every possible polynomial that exists. And there's infinitely many of them, but there's a big thing in here that says polynomials in any possible form, and this is me thinking, any possible form. So x squared is in here, but so is negative x cubed plus 1. And every possible combination that makes a polynomial is in here. Are these 2 in this set? Okay, in this right here, I subtracted 2 things that were in this set of polynomials. Everybody okay with that? Is my answer also in this set of polynomials? Yeah. Is there any chance that if I added, subtracted, or multiplied, and I know that it was subtracted, added, and multiplied, if I did any of those with 2 or more things in here, do I ever leave? No. So we are going to say that our set of polynomials exhibits or demonstrates which property do you think? Closure. We're going to say that closure by definition. We're just going to say a set or when a set. And I'm going to write set here as a vocab. We're not going to formally define it all the way. It's just a collection of stuff. And I'm going to say collection of things because that seems more natural for me. Closure simply means that when we have a set, a collection of things, and combine members of that set, and I'm going to use elements instead of members, of the set, which the 3 ways that we combined just now were addition, subtraction, multiplication. They produce something that was also where? The result is also, and if that's not immediately clear, we're going to scroll up here in a second, but I'll let you guys catch up. There's a last phrase we're going to make. If you give me a collection of things and we combine them, like we did just now with if in this example, we have a collection of people in here, and if they were combined and a new person was made, would they also be in this room? Yeah. When we did it with polynomials, and we had the set of all the possible polynomials, and we combined 2 of them, was the answer still in the set of polynomials? So when we look at this, if we want it more generalized, instead of just saying the set of polynomials or the set of Holloway's classroom, if we combine stuff in that set, then the result is also in the what? Classroom. In the classroom in our example, or in the set of polynomials, or in the set, just whatever set we're looking at. Does that feel okay? I'm going to write that down because I can't tell for sure. The result is also in the set. If you add 2 polynomials, you get a polynomial. If you add 2 real numbers, do you get a real number? Yeah. If you multiply 2 real numbers, do you get a real number? If you subtract, do you also? So we say the set of real numbers is closed under those operations. Can you think of a set, any set that exists that's not closed? Or that doesn't have closure, we could say instead. Ooh, say that again. The imaginary numbers are not closed. If I add an imaginary to an imaginary, do I get an imaginary? You say no, but what's 2i plus 3i? So it's 5i, but I'm okay with that. It still has an I. Is it still imaginary? So they're closed under addition. Okay. Is it true if I do the same thing of subtraction? Why? Louder, Hawaii, because I... So I like where you're at, but we're doing subtraction first. Can I get out of the imaginaries by subtracting stuff? I think I can. What's I minus I?
0.
Is that an imaginary number anymore? No. So they're not closed under addition. Okay. And multiplication is where Hawaii went. are the imaginary numbers closed under multiplication? Why not? What did Hawaii say? And explain it to me, because I don't know what she meant. What's I times I? Good, and what's I squared? Negative 1. If we take I times I, imaginary times imaginary, is it imaginary after that? No, so we weren't close. And we see that that idea exists. It's awesome. That turns out to be probably the most important idea that you guys don't care about and that we don't truly need in here yet. But this is a very big idea in mathematics. Huge importance to this. Okay, we're going to do a brain break, and it might be the end of the hour. Short, but it'll also be easy. On your way out, I want you to write down homework 3.2, page 131. I want you guys to do problems 1 through 9.
Odds and evens?
Both of those, yes. 1 through 9, 10 problems this weekend. It is addition, subtraction, multiplication of functions. Most of you have your phones. Once you have the assignment written down, you can pack up, peace out, and have a wonderful weekend.
You want us to leave the bell ringers on the desk?
I'll grab the bell ringers Monday so that you guys aren't late for second hour. Thank you. I should have done that. I forget every Friday. I might actually spin the wheel to see if I'm taking them this week. But we'll see. All right, later, Raiders.